Hey there, Science 10s. So today I only had two students in the meeting. So we had talked about ionic naming, and some of you are doing pretty good on that, but some of you are making errors. And so I really wanted to clarify and go through some things to help you, because this week we are going to have a summative on ionic naming and also some new stuff that we're learning this week on molecular naming. The first thing I want to talk about is I put the instructions at the top of every Google test form that you're doing, but a lot of students are not reading it. And unfortunately, you're being penalized for not following instructions. So, for instance, when you are writing formulas, part of the formula is the state, and you do not get full marks if you don't write the state. So if you just wrote for sodium chloride NaCl, there's no state there. You are not getting full marks. But then if you go and you add that solid, that state, now you get a full mark. So that was the first thing I wanted to talk to you about: reading instructions, writing states. And then again, when you're writing the compound names, they're not like people's names, right? So it's not like, Michelle Ladine, where I have to use a capital M and a capital L. That's not correct. You can just use small letters. And in fact, that's what you need to use: small letters for the names of each element. So that's only in the name, right? Remember that the formula comes from, you look up on the periodic table. So you can't write Na. Well, that's not what the periodic table says. Periodic table says capital Na. Okay, so I know this is a lot of rules and it does get confusing, but if you just keep doing your practice, you guys will get the hang of it. You're doing really well so far. Another reminder is that when you're having a multivalent ion in an ionic compound, so like copper, for instance, when you look up copper on your periodic table, there's more than one charge for your copper ions, right? And so, you look up copper and you see that it says Cu, and then there's either a 2+ or a 1+. So to show me that you're understanding that this is a multivalent, when you are writing the name, so the example was copper phosphide. So you got to decide which copper is it. Is it the 2+ or is it the Cu1+? And so the secret is to look at that anion, the second ion. And we know that phosphorus is phosphide ion, and this is a group 15 non-metal, so he's P3-. And so copper is not correct. This is going to be Cu, and I need 3 of these, right? So Cu3P, solid. And so it's the copper 1 that I'm using. And so I'm not writing I, I'm writing a capital letter instead. Okay, so copper 1. This is the copper ion, not 2, but 1. And I'm using a capital Roman numeral. Okay, so and again, I use a capital C and a small u, a capital P, like oxygen is capital O. So again, just read your periodic table correctly. And then reminder that your polyatomic ions are going to have ATE or ITE endings for those anions. Otherwise, it's going to be a non-metal that you see from your periodic table on the right side of the staircase. And those guys, you have to make sure to change their name to an IDE ending when it's the second element. Okay, so a couple of examples just to review with you. This is one that a lot of students did. So you understood, and you guys did a great job here, understanding that the PB, the brackets IV, means it's the 4+ ion. So you looked on your periodic table and you said, oh, this guy's a multivalent metal. And then you looked at this and you said hydroxide. Oh, that's kind of funny. To me, it sounds like there's an O and hyd is an H. Oh, there are 2 atoms in this ion. This is one of these polyatomic guys. And I look him up on the chart and I see that he has a negative charge. So that means that in this particular ion, there's 1 O and there's 1 H, and they share together a negative charge. So I cannot write PbOH4 because this formula, when I write that, tells me this. It tells me there is one Pb, one O, and 4 H's. And that is not correct. When you do it correctly, you must write a bracket around the polyatomic. Why? Because this 4 is a multiplier both for the O and for the H. So that means there are 4 O's and 4 H's, and there is one Pb. This becomes very important, guys, once we get into our writing and balancing chemical equations. So right now, yeah, this is correct to have it in brackets. If you don't put it in brackets, it is wrong. And it's going to come into play really soon here, especially when we are starting to do our naming of compounds and balancing compounds, writing our reactions out. Okay, so a lot of students were confused on this question where, again, it is iodate. And so I should immediately look at the last couple letters there and think to myself, well, that has an ATE ending. So I know this is going to be a polyatomic from the table. And then I go and I look it up and I find it's IO3 1-. It is a polyatomic ion. It has one iodine, 3 oxygen, and they share together a 1 charge. A lot of students thought it was iodide, the group 17 ion, the nonmetal iodine. That was not correct. Okay, so again, you look up the ending. Is it an ATE ending? Then it's probably going to be on the polyatomic table. Okay, a couple more errors that I noticed just to caution you guys. So again, this is the one I talked about. Cu3P is not copper phosphide. It is a multivalent, and you have to indicate that by using a capital number in brackets, right? Copper 1. Okay, so I said to a lot of you guys, so which copper ion? It's multivalent. You must show that by in the name having those brackets. Okay, and here's another one that a lot of students got wrong is that, remember this first element is a metal and the second element is either a nonmetal or a polyatomic ion. And we always use the IDE ending of those nonmetals, the ones from the periodic table. So if it is nitrogen from group 15, he gets named his IDE ending name nitride. Phosphorus, phosphide, arsenic would be arsenide. So there's the error, is that a lot of students left it just as it appears on the periodic table, and they forgot to make it into the IDE ending. Okay, so what's happening this week? May 4th week, we are moving on to a new type of naming. So when we learned about the ionic compounds, and we talked about ionic naming, we were really focused on the fact that there is a metal first and then a non-metal. Or there was a metal first, and it might have been a univalent or a multivalent, and then a polyatomic ion from the table. But you'll notice that in both cases, the first part of the name comes from the fact that there's a metal, one of those elements on the left side of the staircase of your periodic table. So it could have been a univalent metal, guys like sodium who just have one charge, or it could have been a multivalent. We just talked about copper and we said, well, he could be 1+, or he could be a 2+, right? There's more than one charge. Then there's either a non-metal like chlorine becomes chloride, or oxygen becomes oxide, or there's a polyatomic, we just mentioned iodate. So when we're starting to talk about molecular naming, this is a whole different world, right? We're looking at non-metal and non-metal. With the molecular naming, there are no metals whatsoever in these compounds. So that means that there's no ions either, because we know that that metal is always a positive ion, right? A cation. And we know that the nonmetal is gaining electrons and forming an anion. So there are no ions when we're looking at molecular compounds. We are talking about molecules and sharing electrons. So you name these normally, the name of the first element goes first, but this first element is going to be a non-metal, somebody from the right side of the staircase on your periodic table. So here's an example. Cl, well, what's Cl's name? His name is chlorine. You just look him up on the periodic table. What's the second word in this name? Well, the second word, oh, you look that up. You guys know that one. That's ox. And now we need the IDE ending, right? So that second word, just like we did before here, non-metal, chloride, oxide. Well, again, here is oxide. Here's what's different. Here's what's new is that you now need a prefix that tells you how many atoms there are. So I have a chart for you guys. So if you had just one atom, it would be the prefix mono. If there's two, then it's di. 3 is tri, and so forth. So this di, this is a prefix. So the number goes after the element symbol. But what you also see is that the prefix goes out to the front of the name. So dichlorine, then you look up 7 and you see 7 is hepta. So again, it's a prefix. It goes out front of the nonmetal. And heptaoxide. Now that sounds kind of awkward, so we're just not going to include the A there, just heptaoxide. Okay, now there's a couple of examples where you will also find that we have non-metal, but it only has a one-word name. So methane would be an example of one like that. And so these one-word name guys are found in your data booklet. So if you have a molecular compound that has just one name to it, that's on page 3 of your data booklet. And all you have to do is just look these guys up. So you look up methane and you see, oh, methane, he is CH4 gas. So all these guys, you're going to also be given the state because they're not like ionic compounds where they're all solid. Some are gases, some are liquids. And so you'll be given the state and you just have to write it out. Okay, well, we do have some more stuff to work on this week, and I'm going to leave that to some professional videos, properties of ionic and molecular compounds, how to use a solubility table, 2 assignments this week. So the first one's coming out today, finish it by Thursday so I can give you feedback on molecular naming. And then you will have a summative that's on ionic and molecular. So you have to know the difference between how to name these 2 different types of compounds. Okay, if you have any questions, you're welcome to email me, michelle.ledeen@ghsd75.ca. Talk to you later.